How's everyone doing this morning? Good. I'm tempted to make people get a little bit more enthusiastic. I know everyone's tired, and I mean, it's 10 a.m. or 11 a.m. I don't know what time it is. I'm in a different time zone in my head. But let's try that one more time. How's everyone doing? Great. Yes, that's cool. I feed off of everyone's energy, and especially since I'm jet lagged, that's necessary. Well, thank you very much for the wonderful introduction. You stole one of my questions that I always ask, but that's fine. We're going to dive right in because we only have about 40 minutes, and there's a lot of information that I want to cover. So before we actually get started with a lot of the technical things, and I promise you there's going to be live demos, it's not just look at all these PowerPoint slides with hand signals, but this session was designed to get you thinking. It was not designed to make you an expert, and you'll be surprised how many times people are like, I sat through that 1-hour presentation and I don't know how to do the end of the pipeline. Okay, it's just designed to inspire you. It's designed to get you excited. And it's not about how to do whatever at the end of the pipeline or whatever I show you, because I give you all of those resources at the end. I created a nice big GitHub repo for you that you can go off and play with and research everything that I do. So we're going to dive right in. And I think it's pretty safe to say that life runs on code. I mean, I know it runs on code, and so do our jobs for everyone in this room, because nearly 95% of you raised your hands for being a developer. But I mean life in general, what we rely on, what your families rely on, what your kids rely on, right? Code is such an integral part. So what does that actually mean in the big picture? And how can we, in our industries, in our enterprises, in our software development, and our continuous integration, delivery pipelines, how can we really make sure that we're delivering with that life expectancy, that life dependency? How can we deliver with that at the forefront? I love this little graphic, particularly this little luxury car, because we can't legally say that it's something that rhymes with shmashla, but if you think of something that would rhyme with shmeshla, a vehicle like that uses 120 million lines of code. In fact, I was more surprised to realize that it uses like 4 times as much, almost, as a space shuttle, which uses 400,000 lines of code. Now, when I said that life runs on code, chances are, well, I come from the United States, so not everyone in the United States has a Tesla. I know in Europe and other countries, those kinds of vehicles are a lot more common. But even if you don't have a Tesla, or you don't have a spaceship or a space shuttle in your backyard, life still runs on code, right? The traffic system that we use, that you rely on every day when you're driving to work or taking your kids to school or going to the movies, that uses 5 million lines of code. Or my favorite is this little guy right down here in the bottom right-hand corner. That's actually Scott Hanselman. I work with him at Microsoft. If you've ever heard his talk about open source technology and healthcare, and specifically his artificial pancreas, his life literally and figuratively runs on code. He has had an artificial pancreas with open source technology, he calls it body hacking, keeping him alive for the past 3 years. It uses 160,000 lines of code. And it's something that we wouldn't even heard of 5 or 10 years ago, even though he's been working on diabetic research and everything for about 10 years. But this type of dependency, where code is such an integral part to our lives, is something that we're now starting to have to see as far as a shift, as far as where industry and our careers are going. So especially with the concept of containers, how does that change how we do our normal daily workflows? How does that change our development? Maybe even outside of the traffic system or body hacking, maybe we need to just consider a little bit smaller, right? You go to the mall, retail stores, everything has code, security cameras, registers, revolving doors, escalators, elevators, your smart vehicles, even if it's not a shmeshla, your smart homes. I just upgraded my sprinkler system, and I got a rebate from the county that I live in to make sure that it was water efficient and smart, something that could automatically connect to the weather stations that's not radio frequency. And now that is something I can control on an app when I'm 8,000 miles away from home, right? We have so much smart home dependency. We have smart devices. The average home has something like 20 different devices now, between Rokus, Chromecasts, iPads, iPods, phones, Androids, Macs, PCs, Surfaces. We're starting to see so many more intelligent experiences, even down to baseball stadiums or sports stadiums and concert venues. All of that has code. So there's so much more from a delivery perspective, and there's so much more emphasis that's put on us as developers to deliver this kind of connected world. And it's said that in 2020, which is in just 2 months now at this point, that we're going to be entering what's known as the ubiquitous era, where it's no longer homes have just 20,000 devices. If you break it down into microservices and apps and technologies, Netflix, Hulu, Amazon Prime, the amount of things that are being consumed by an end user on a daily basis is going to end up being in the thousands, right? That's the next generation. So we really have to start shifting our mindset and figuring out how we can adjust with that. That's where the argument for microservices and containers really comes in. And I'm also going to talk about waffles in this session. So aside from just making everyone hungry, we are going to be technical, but you'll see why I'm going to tie in waffles. I know the title of this session in your pamphlet said Master Tooling for Containers. That was a little boring and not exactly exciting as a title, so I renamed it to a superhero theme. So I'll talk about superheroes, and I think I'll end up renaming this as well to Containers, Superheroes, and Waffles, because there's nothing more clickbait than that. But you'll see why. So, of course, my introduction took away one of the questions I normally ask, which is how many of you are developers? Just by a show of hands, how many people would identify more on the ops side of things, or the artist formerly known as systems engineer? Perfect. And then how many people just wear whatever hat their boss tells them to wear? Everyone's hand should go up, or we all need to have a conversation with your boss. Because you got off work today. No, I'm just kidding. But for the developers in the room, right, and that's obviously most of us, we need to create applications at a competitive rate. We need to keep up with this life depending on code. And we don't want to worry about IT. But we all know the age-old saying, it works on my machine, it's your problem. It's your server's problem. I know, give me the keys, give me the floppy disk, the USB disk, the zip disk. We'll go back to 2000. I'll go over to the server and I'm going to make it work. Obviously, that doesn't work in today's world. So as a result, the developer feels as though their productivity and application innovation become suspended when they have to wait on IT. What is the root cause of that? It means that IT is the bottleneck to a developer. In a traditional sense, the IT is stopping the ability for the developer to move in an agile direction. But from an ops perspective, for like the 7 of you that raised your hand, and by the way, I spent 10 years as a systems integration engineer, which was a fancy word for operations, prior to going on to the DevOps side and developers. But we can't just give you unsolicited access. I'm definitely not letting you anywhere near my servers with a zip disk, or a USB disk, or a CD-ROM, whatever. I need to manage security protection. I need to maintain corporate compliance. But since I'm not natively a developer, I'm unsure of how to integrate unfamiliar applications. I actually want to work with you. I don't want to be the bottleneck. But I can't focus on both server protection and application compliance. So I need you to focus on the security of your code, the security of your development pipelines, the security of the tools that you use, and I want to actually work with you to have a common goal. The only difference is you as a developer are directly incentivized to work against me, and I am directly incentivized to work against you. Because my job as an operations engineer, putting on my ops hat, is to keep the lights on, which means I want as little change as humanly possible. I want this life depending on code to make sure that life is sustained and that there's no changes. But you as a developer that wants to compete with this new generation, this new era, you want to make sure that there's as many changes as possible, be as agile and fluid as possible, which means you want to move fast. And as a result, we end up working against each other. We need to shift our end goals to the same end goal. And that's going to be the same even when you're working with containers, if you're working in a traditional sense. I don't care if you're dealing with a web app. I don't care if you're dealing with cloud. I don't care if you're dealing with on-prem. We need to make sure we're first moving in the same direction. And to do that, that means recognizing what our stress points are. And I love showing this slide because it says IT stress points. So I always see a sigh of relief from the developers, like, oh, gosh, whew, sigh of relief, right? It's IT. It's the IT person's problem. It's not my stress points. No. I mean information technology. I mean if you touch technology, if you write software, if you support the infrastructure software runs on, if you have anything to do with this life running on code, these are our stress points. And therefore, they are our collective and shared responsibility. We all need to worry about security. We all want to focus on efficiency. And we all have to support this rapid innovation that our industry is heading in. So in order to make sure that we're aligned in the same direction and we're not incentivized to work against each other, we need to make sure that we're using the definition of DevOps that my team at Microsoft, and that has been quoted in several DevOps books around the world at this point, the definition that we stand behind. And that is DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on this slide is value. Because if you're not delivering value, what are you doing and why are you doing it? And more importantly, how do you know if you're delivering value? How do you gauge that? Do you have telemetry, metrics, insights? People think that it gets a little bit more complicated when you start tying containers and everything else in. But I'm going to show you in a demo how containers don't actually change anything. It's the way that we can approach it. As developers and operations, we need to make sure that whatever we're doing at the heart of it has a value as the end goal. Because if both of us, developers, operations, jacks of all trades, those of us who do what our bosses tell us to do, which is everyone in the room, right? If all of us is moving towards that same goal, where our goal is to deliver value, we're no longer going to work against each other. So then now why containers? We've understood that the industry is changing. We now understand how value is at the center of everything. But how do containers really empower and enable this? For the developers, it enables this write once, run anywhere application architecture. It sets us up for microservices. And from the ops perspective, it gives us portability. It gives us standardization across multiple environments. I don't care if it's test, dev, QA, canary, prod, blue, green, A/B, doesn't matter, right? I have abstraction, but with abstraction becomes more complication. So we'll talk about how we can simplify that. There's higher compute density, and it gives me the ability to scale. But when I say containers, I'm not only talking about Kubernetes, which is always one of those clickbait buzzwords. Oh, it says Kubernetes. Go to that conference. It's the CTO, right? I'm talking about just a container in general, and we're going to talk about that. Now, remember that this talk got renamed to also have a superhero theme. So in case anyone got snapped by Thanos' fingers from Avengers Endgame, we're going to review what a container is. It's not a virtual machine. You'll be surprised. I've been doing this talk. I've been talking about Docker containers, Kubernetes for 5 years now. I still remind people it is not a virtual machine. It's not even a real thing. At the end of the day, it's just an application delivery mechanism, and it uses process isolation. So if your background is more Windows, it gets a little confusing because it's based on Linux kernel features. You have namespaces and C groups. But the easiest way and the simplest way to think about it is it's a waffle. And here's why. How many people, this is actually a little bit of a misleading image because it has butter, but how many people like eating waffles completely plain? No syrup, no butter, just bread. There's always one. I need to buy you a waffle. Oh my gosh, there's always one. Personally, I like eating with all these other things, right? I want whipped cream, I want strawberries, I want blueberries, give me blackberries, whatever, right? Because you know what? This waffle becomes the delivery system for all of that extra happiness or value to my stomach. That's all a container is. You're using it to deliver value, but it doesn't change the code, and it doesn't change the security and the way that we have to approach it from a value add perspective. So let's make sure that we understand the difference between virtualization and containerization. Two common types of virtualization. Either your hypervisor sits directly on top of your bare metal, or it sits directly on top of your OS. Maybe that's Hyper-V for Windows Server, maybe that's VMware, whatever it is, doesn't change the fact that you have individual VMs with individual guest operating systems, individual dependencies, and individual applications. But in a container, things change because you have the Docker engine that kind of sits there, that sets you up for an encapsulated runtime, for that application delivery mechanism with its own set of dependencies, its own application, and it can run on whatever the host is. Things get a little bit more complicated here when you start playing with Windows containers, because the kernel version actually matters, but that's out of the scope of this talk. Let's make sure that we also understand how container layers work. And this is important when you're approaching it from a development perspective, because I can't tell you how many times I've gone into customer meetings And somewhere in the middle of their production image, they have an SSH key baked in, a personal access token, a database connection string. Remember, anything that's in the middle here is a read-only layer. That means I can access it from the top, from the container itself. That means that now there's a security hole. If you're running this container as a root user, now I have also another security vulnerability. I can jump out of the container and attack the host, right? So the easiest way to think about it is now it's a cake. I know I said I talk about waffles. But remember, anything that's down here at the bottom layer, I can still access. This is why we also talk about using multi-stage Docker builds, or setting your pipeline up to do certain tasks that have sensitive, secure information, to do those first before you actually package and bundle something that's going into any kind of public environment, right? You want to make sure any of that's encrypted, and oftentimes what you need at build is not what you need at run. And so you'll see that as a best practice for why we rely on things like multi-stage Docker builds. Advantages of using containers, we kind of already talked about, right? We know that it enables this write once, run anywhere, but now it gives me the ability to iterate quickly. It gives me an agile delivery system, and it gives me something that's immutable. But you have to be careful what is immutable, right? You have to be careful about the SSH key or the personal access token. I've seen images from big companies in production with highly sensitive information to production databases. So we really want to consider that. From an ops perspective, there's cost savings. I'm not managing 7 different servers. I'm not trying to be reactive as opposed to proactive. I have a more efficient deployment method. And I can even do elastic bursting. I can go from the public cloud into the private cloud and vice versa. So now, as much fun as all of this is, looking at my hand signals, I'm going to go into a demo. And we're going to see certain things that we can do from a developer perspective to maybe streamline how we can get things container ready. But the spoiler of how this demo works is at the end of the day, it doesn't matter on the tools that I use, because you have to remember that the end goal of all of this that I'm going to show you is delivering value. So I'm going to end the show of PowerPoint. And I'm going to go over here, and I have an application up on GitHub. Don't worry, you don't have to take a screenshot of this because I have a QR code at the end. But this application is a Java application. It's a Spring Boot application, has Maven packages. I did not write this application. I took it because I wanted to have something that was more real world, something to show how you can maybe make this abstraction a little bit easier, trying to get things into containers without making it overly complicated on your end as a developer. But I wanted to prove that these tools would work for something that was even ridiculously complicated. And Java is very specific. So I figured what better way than to take somebody else's code that I've never seen before, have nothing to do with, and see if I can get it working. And I actually did this for the first time in a webinar, and now it's actually on YouTube, but I did it within 25 minutes, and that was even building a pipeline. Today I'm going to show you the end result of that, because we don't have as much time to go through it from scratch. But I have the code base up here in VS Code. You'll notice on the left-hand side here, I don't have a Docker file. I don't have a Kubernetes manifest. If you're familiar with Helm, which is the package manager for Kubernetes, I don't have a charts directory. I don't have anything that can make this container native. I have a pipeline. We know the basics that I would have to do, Docker build, Docker push, run it somewhere. But I don't have anything that can actually make it container ready. So from a developer, where would I start? I'm going to use a tool called Draft. Draft is open source. There's other ones like that. Scaffold is one. But Draft, I think, is the easiest to get involved, because I can get started and get it container ready with just 2 commands. So all I have to do is type draft create. And by the way, before I hit enter here, if I zoom out, and we'll zoom in over here, I'm using Docker for Desktop. I have a Kubernetes cluster running locally just as part of Docker for Desktop on my Mac. I'm not even touching the cloud. This is just as though I have code working on my system, and I want to see if I can get it to run in a Docker container, maybe in Kubernetes. So I'm going to type in the words draft create, and I'm going to hit enter. It's going to automatically search for the language that exists in my repo. My application's probably not written in YAML. It's not written in Shell. Oh, I detected Java. OK, I'm ready to sail. So what did that add? That actually gave me a Docker file. And you're going to notice it gave me a multi-stage Docker file, right? Lines 1 through 4 is one stage, and then line 6 starts a second stage. And it gave me a charts directory, where now I have a series of templates, including a deployment YAML. And if you're not familiar with Kubernetes, you have a declarative syntax that will say how many pods you want, what the image pull secret is to get private registry information. You have all this information. It gave it to me with 1 command. There's no magic here. I promise you can get started also with one command. But there's a few things I want to kind of go over. So while it gave me a multi-stage Docker build, I need to make sure that my application's working on the right port. This application works on port 8080, so I'll type in 8080 here to make sure that those ports are exposed. And I don't output, as part of my code, I don't output anything with dependencies, so I'll just delete that, and I'm going to save that Docker file. Now, anything that exists in the Docker file, I need to call, whether I'm using a web app or I'm using Kubernetes. So I'll go over here to that charts directory, and you'll notice that if I look at the templates, there's actually values that is repeated several times. That's because I'm controlling any of this. Helm allows me to use variables and parameters. I'm controlling any of this with one file. So it means I'm simplifying anything that I need to manage, anything I'm going to repeat. So I'll go over here to values, and you'll see any of those things that I kind of reference, even replica count, just to show you deployment before. Here was line 9, which was replica count. That's right there on the values file. So I'll go ahead and change the internal port to port 8080. And we'll zoom out here just so I can see. There's also resource requests and limits. If it's an application delivery mechanism, I need to make sure that I'm setting the proper amount of resources that I want the application to have. So I'll choose 100 here. I'm going to do what every good developer does and use find and replace because I don't want to mess up. So I'll do 100. I'm going to change this to 256. You can zoom in and see what I'm doing. And then I'm going to change 128 to 512. And I'm doing this because I know my application needs a little bit more. Now I'm going to save. Now, without doing anything else, I'm just going to make sure that this works in Kubernetes. And I can test all of this locally. I don't even have to worry about the cloud. All I have to do as a developer is know what is needed from a process perspective and what port my application runs on. So I'll clear the screen down here, and I'm going to do draft up. That's going to release the application into my local Kubernetes cluster. I would be able to interact with it the same way I would if I were dealing with ops or anything else. But I'm going to show you the value of this. So I have an alias called kubek for kube cuddle or kube control. I know not everyone wants to cuddle with their command line, so I just do k because it makes everyone happy. And I'm going to do k get pods. And we should see that the Spring Boot pod is up and running, and it has been for 21 seconds. This is live. I'll do k get services. I'll hit enter. That's also been up and running for 29 seconds. I could do k logs and tab Spring Boot and see the logs that are running. But if I'm a developer, I really don't care about any of this. All I want to do is make sure that the application works, aside from just running Java locally on my system. Before I check it in, I want to make sure it's going to work with any of my ops stuff. So wouldn't it be better if I could directly connect without having to worry about anything else? Yes. So draft gives me a third bonus command where I can do something called draft connect. And rather than having to port forward or create tunnels or go over to a deployment or a service, this is actually going to create the proxy for me. And it's going to give me a tail of all the running logs. I can see this connect line right here is where it's actually routing the Spring Boot WebSocket chat application on 8080 to a local host port. So I'm going to copy that local host port right here. We'll go over to a browser. I'll zoom out. Go over to a browser, paste that in, and I should see the application up and running. It takes about 60 seconds sometimes. Tomcat is slow. But I'll type in, and we'll see, hello Copenhagen. That's awesome. That was my local development. Now, I could show you how we do pull secrets and editing and all this stuff, but since 95% of us are developers, we don't really care about that. The question usually is what do I do after this? What about getting in the cloud? Well, I told you how important it is to consider security and how important it is to understand that containers actually doesn't change anything. So if we go back over and we talked about how layers work and how that cake works, let's take a look at just this base Docker file. First off, the part that I really care about, aside from, I do care about the base image up here, but for the purpose of today, I really care about this section. Because for one, I'm using a public image. That's not secure, and that's probably not in alignment with my corporate policy. I don't have any kind of run level or user level, so this is running as root. That's not going to pass any kind of deployment. So I'm going to need to make sure that I change at the very least those two things. In fact, prior to me getting here, I had already, let me undo that, I had already deployed this out using the code that I currently had that I checked in before with that base image that you just saw. And so if I go into Slack, and we'll talk about this also from a chat ops perspective, but from Slack, you can see on how I have notifications. So I'm actually using JFrog Artifactory, which allows me to scan all the Maven repositories, right? I told you, I'm trying to do something real world. I also have JFrog X-Ray. Spoiler alert, there's also aqua involved. There's also corporate policy being handled as far as what can happen from Git from a product called Tree. I'm trying to set any kind of policy perspective. But you can see right here, the X-ray scan report failed. So if I drill down into this, because I have that telemetry and those metrics, I can see right here that I have a high concern. I have 20 violations and 112 different security concerns. I have insights that gives me data into that. So if I go back over to VS Code, and let's just say that I change this. Remember, all I want to do is change that one line where I comment out this line, and I add in an image that I own, that I patched, and I set a user level. I'm going to save this. We'll zoom out here. I'm going to check in that one file, and we're going to say patch docker. We'll commit, and we're going to push. Now, this is going to take some time to fire off, but we'll see the end result afterwards. We'll see that data and see how many of those 112, let's go back, 112 security flaws and violations I was able to resolve. Now, from a DevOps perspective, what are the tasks that we're going to have to do? I'm going to do a Docker build. I'm going to push it somewhere. It's probably going to be a private repo. What happens after that? I don't care if it's running in a container or if it's normal code. You're going to do some sort of scanning, whether that's visual scanning, unit scanning, security scanning. That's part of the pipeline. You're going to compile it, you're going to test it, and then you're going to push it to some sort of dev test environment. Then you'll go to QA. Then you'll go to production. So let's take a look at what that pipeline looks like. This is a CI/CD platform that's specifically designed for Kubernetes called CodeFresh. I also have Jenkins set up, and I have Azure DevOps set up. And I did that intentionally to show you the tools don't actually matter. Once we simplify the abstraction, once you know that it's working in Kubernetes, once you consider the security, your base image being pulled from a repo you own, your root users, your Git credential scanners, once you consider that, the pipeline part doesn't change. So if we take a look at it, I clone my code. In this instance, I'm using JFrog to actually make my jar file because I'm using a private package feed for my Maven repo. I build my Docker image, I push it. If I'm using Kubernetes, I'll package my Helm chart up. Then under testing, I'll actually go over and I'll lint that Helm chart, right? I'm doing the same thing that I would do if I'm linting my code. And then I end up publishing all the info over to Artifactory, which again is a binary investigation tool. It's where I can get any of my data all in one place. I send any of that info over to Slack. I do that so I make sure everyone on the team is in alignment, right? That we all know what's going on and we all have those insights and that telemetry. Whether you're dev or whether you're ops, we know the security or the health of our application. I can do the same thing with Aqua. So for example, I have Jenkins right here, and I'll refresh this. It looks like I just lost internet here. But I can do the same, now it just reconnected. So I can do the same thing with Aqua, where I can go into this particular build, which failed. This is the one I ran before, 2 hours ago. And you can see the Aqua security scan failed. If I go and open it up, I can see the Aqua security scanner information. My image is non-compliant. It doesn't matter if I use X-ray or Aqua. It matters that I have insights and telemetry into knowing if I'm delivering something of value. If it's full of security flaws or CVE exploits or whatever's going on, there's no way I'm delivering value. But whether it's running in a container or not doesn't change the fact that this would be a security flaw. Containers gives me another way to isolate and see that visibility as opposed to scanning all my different servers, right? And I can do the same thing I told you with Azure DevOps. So you'll look at the pipeline. I'm going through, I'm doing lint, I'm packaging up my Helm charts, I'm building an image. In this instance, I log into Aqua. I also use the Aqua image scanning tool. All Azure DevOps is a task runner. It's going to run those same tasks that I define in Jenkins or CodeFresh or Travis CI or Circle CI. It doesn't change. I can just drag and drop from a task runner here, right? But I still get that same information. In fact, here's the pipeline where the image would be allowed. So I can see all of that's good. I can go in and I can see any vulnerabilities. I can see the layers where those vulnerabilities live. I can even go over to the portal here, which was, let me make sure that I'm signed in. Try logging in. This was, again, what I ran before I got here. I'm going to click on images. We'll click on CI/CD scans. And I can see the latest one just scanned and there was no issues. But previously, before I got here, there was 4 high security issues. I can get that same information from X-ray that I showed you, where I can see the violations. It doesn't change regardless of the tools. Draft enabled me to get started from a developer, But then from an actual security perspective, remember, one of the big stress points we care about is security. It enabled me to have insights into that. So I'm going to go back over to Slack and see if I got any notifications. It looks like I did. And now, just from making that change, I have information that the build artifacts passed and my scan report passed, and 0 alerts were generated. And right from Slack, I can go ahead and choose to approve. And since you know I also have Azure Pipelines, I also got a succeeded note there. Just to show you how many violations, because I had insights into that, I was able to remove all 20 violations, and now there's only 2 low security flaws, which means just from owning my image and making sure that it's not root, I resolved 110 security flaws because I knew about them. So it doesn't matter so much that it's a container, it matters the value that you're going to focus on. So let's go back over. There's one more thing of value that I'll show you. The other benefit is I can also use things like application insights and telemetry to make sure that the health of my application is up and running. And you can do this on Google or Amazon. I have my stuff running on Azure, but I'll show you I can see the server response time. I can even see the server requests. I can see the health of my cluster, how many pods I currently have running. I can see the status of the bandwidth and the DNS requests. I can see every single ping. I can create a dashboard that gives me how many nodes are even up. I can have that telemetry aside from just the security perspective. I can have insights into what's actually running on the cluster in real time. So I'm going to switch back over now to PowerPoint, and we'll kind of recap here. All right. So what just happened? I have code on GitHub. We know that Azure DevOps was one of the pipelines, but as I showed you the spoiler, it didn't matter if I had Azure DevOps, CodeFresh, which was again Kubernetes CI/CD, it's specific for Kubernetes, or Jenkins to run the Kubernetes pipeline. The rest of the tasks didn't change. I still had to build and push the code. In this instance, I used JFrog Artifactory. You could use Azure Container Registry. You could use Google Container. You can use Quay, Docker, anything that's a private registry. I used JFrog X-Ray or Aqua. You could also use Twistlock or Trivy or Anchor. It doesn't matter as long as you understand the principles of what you're doing from a DevOps perspective, from a scanning perspective. And the spoiler is that it doesn't actually matter even if it's running in a container. We still care about the security and the health of the code. One of the things I have to make sure that I always do before I run this demo is make sure that anything that I'm defining from a Maven package repository in my POM file is constantly updated. But there's no way that I can have insights into those dependencies unless I have tools that can tell me the health of those dependencies. So again, just in case we got snapped by Thanos, in case you're wondering what Kubernetes is, and this is a little high level and fast moving for you, it's just an open source container orchestrator. It's a big picture of how I can orchestrate several microservices, but it's not the only answer. You can also use web apps, you can use Azure container instances, Google calls it something else, but ultimately it's just Docker run in the cloud, and then you don't have to worry about managing your cluster, but Kubernetes is on the back end. But the end goal of Kubernetes was it was designed to automate deployment, scaling, and management of applications. You can only manage and scale your applications if they're going to deliver that kind of secure value, and you have to have insights into what's running. If it was designed to simplify automation, how do you simplify your security and your code architecture? One of the easiest ways to focus on getting started and at least testing it was using tools like Helm, which is a package manager for Kubernetes. You can think of it like Maven, apt, pip, NuGet, right? It's the de facto package manager. And then Draft helped me simplify that. I didn't even need to touch a cloud for me to test anything locally. And then all I do is I can check that in. My ops person can go in and make any operational changes. But for the most part, it was a great development tool so that I could at least see what's going on. But then there's all these other tools, right? I mentioned quite a few. At the end of the day, it doesn't matter what tool you're using on here if it's not going to deliver value. So the easiest way I tell people to think about this and approach this is with KISS. And if you're thinking of a band, it's not a band. And if you're thinking of calling your neighbor a name with that last letter, don't do that. That's not very nice. My definition is keep it super simple. You saw that no matter what pipeline I used, whether it was Azure DevOps, whether it was CodeFresh, whether it was Jenkins, the tasks didn't change, right? At the end of the day, I just go back to the root of what's the simplest way that's going to deliver value. Even down to the Slack notifications. I've heard people like getting super fancy. They're like, I wrote a function and then it has a machine learning algorithm and it calls this and it does that. No, the Slack thing uses a curl container and it just posts the message to Slack. Why overcomplicate it, right? Keep it as simple as possible. Another way to kind of think about things from a Kubernetes perspective is Kubernetes is great if you need it. One of the big things that people in the Kubernetes world try to do is write their own operators, their own versions of Helm, and their own CRDs. But not everything needs to be an operator. Not everything needs to be a CRD. And I'll add to this, not everything needs to run on Kubernetes. If you remember the core value of what a container is, ask yourself if you can get the same benefit running in a web app. Any of those security tools don't change. There wasn't anything that was Kubernetes specific aside from maybe draft and understanding command line tools, but your pipeline doesn't actually change. So again, keeping in line with a superhero talk, I'm going to quote Agent Gemma Simmons from Marvel, Agents of S.H.I.E.L.D. The steps you take don't have to be big. They just have to lead you in the right direction. I don't care if you just start very small and you do Docker run on your system or you play with it locally. As long as you're understanding the value add that you're getting out of it and you have some sort of security insight. You can run X-Ray, Aqua, Trivy. You can run any of those locally as well. So you as a developer knows the security of the packages that's running in your code. Remember, you have to worry about the security of your code. I'll worry about the security of the server. It does make it easier when it's in a container because then I can have the insights across the board. You can ask yourself some key helpful questions. What are my main objectives? What am I promising my developers? What am I promising my end users? What are the indicators for those objectives, right? This is some SRE, or Site Reliability Engineer questioning, but this is valid for everyone in the room. You ask yourself what your pipeline will look like, right? We already kind of went through this, but we know we're going to compile, we're going to build, we're going to push that code somewhere, we're going to scan, we're going to deploy to a dev environment. Scanning, by the way, is unit testing, visual testing, functional testing, security testing. And then I can even set up things like deployment tests, gates, deployment approvals. And then I can choose where it's going to get promoted, if I'm going to do canary, if I'm going to do blue-green. No matter what that is, whatever I choose is going to kind of be the same. Doesn't matter the product or the tool. It matters what's going to deliver value. Private package feed is going to deliver value. Private repository, some sort of scanning tool. CI/CD, as long as you have that in place and you have the steps in line, is going to deliver value. At the end of the day, the foundation is the same. Ask yourself, and this is probably one of the best questions you can ever ask yourself, does this add value? Or does this add unnecessary complexity? I have talked to so many people and they tell me about this big elaborate thing that they have running in Kubernetes, but it's not big and elaborate. It's a database and a microservice front end. Okay, run it in a web app. You don't have to overcomplicate it, but you can still set it up in a container to where it can scale, right? At the end of the day, remember that it's just a waffle. Remember, all you're trying to do is deliver value or happiness to your end users, the same way waffles and syrup and toppings deliver value and happiness to our stomachs. Perfect that this is right before lunch because everyone's going to be hungry. Now, there's always that one person, and I have about 2 minutes, so I'll play this really quick. But there's always that one person that wonders, okay, this is cool. I know about all the security. I'm already doing all this great. What happens if I just do all of this by myself? I don't like the cloud. I don't like on-prem. I want to run Kubernetes containers, everything by myself, and manage it as my own operator, right? So focus on myself and my own. I have actual footage of what happens when people try to game the system and try to get ahead without considering things of, again, remember about unnecessary complexity or if it's offering value. Some of you might have seen this video before. It's really popular on Twitter right now. And then wait for it, because in about 8 seconds or so, somebody's going to come in with some helpful tips, which is some of these questions I've asked you, and they're going to stop the chaos and the madness from happening, because this almost takes out a jet. Focus on this little red thing right here. Here comes the little savior to save the day. Boom. Don't do that. Don't try to write things and go off into chaos land unless it's going to genuinely offer value. You have to remember the big picture. This is not going to be valuable to anyone. Other things that I quickly touched on, I also talked about how when you think about security, you can also think about the health and security of your code before it ever touches a container or anything else. This is something called the tree. There's a link again in slides at the end, but it's going to scan any repo that I have. It's going to tell me if I have secret credentials hidden in my source code, if I have dependencies in my source code that I'm not scanning, if I have personal config files, if a git ignore file is included. It gives me a full report of any of that for all of my code components, the people in my organization that have access to that code, if there's secret credentials embedded in that. This is before it ever gets checked in anywhere else to a build pipeline. This is like the gate for you cannot cross over into Mordor. Hopefully there's Lord of the Rings fans in here. You can also set up additional things, and this will work with Aqua or X-Ray or anything else, but you can set up additional Docker tasks. I know some of these pictures are smaller, so I'll read this, but that the from tag shouldn't have latest in it, that the user property shouldn't be root, that the label maintainer should exist, that the health check property should exist, that apt installed packages should all have a version, so I'm not, again, just saying latest even on my packages. And it's funny because while all of these are things I can set from Docker, those are still same things I would care about even if it's outside of a container. So you have to implement security checks along the way, and that's going to help what's going to be able to help you master any kind of container tooling or pipeline. So we're right at time. So any of these best practices we've kind of already gone over. So there will be in the deck that you can grab from the final slide, which is after I kind of talk about myself. The most important thing to remember is my last name is spelled with 2 E's. So if you want to connect with me online, no relation to James Deen of any kind. Pretty much, that's the only purpose why I throw that in there. And then this is what everyone's waiting for. You can scan that lovely picture with a waffle, and you can go to aka.ms/JLDeen, 2 E's, waffle ops. And then thank you very much.